Hi, this is Chapter 11, Lesson 4 on mean absolute deviation. You're going to need your math book. We're going to start on pages 837 and cover all the way through 840, and I would like for you to have a pencil and a pen out for this lesson. Two main things that we're going to cover is first, we're going to learn and find what mean absolute variation is, and we're going to then compare variation. So looking at the real-world link, the tables show the number of points two different teams scored. So you've got Allie's team and Lena's team. Number one asks you to plot the set of data on a number line. So go ahead and take a moment to plot the dots. Now make sure you have solid dots that are actually placed directly on the number lines. So you could see here that how I did Allie's team. And I want you to do the same thing for Lena's team. Now, question number 2 asks you to find the mean of each set of data. Now, I'm going to help you guys out. I'm not going to make you add these numbers up and divide, but and we're going to put a little star, or actually I'm going to use a larger dot in green for you to see the mean. I know it says to do a star, but I couldn't do a star with my little stylus. So for number 2, we found that the mean for both Allie's team and Lena's team are 55 for both of them. Now, question number 3 says for you to find the range for each set of data. Well, let's start with Allie's team. With Allie's team, we have the largest value is 62, the smallest value is 48. When I subtract them, I get 14. Now, look at Lena's team. We actually get the same exact thing. Her largest value is 62, and the smallest data value is 48. So now number 4 asks us to refer to the number lines and then compare and contrast each set of data. So one thing I want you guys to remember is start with telling me what's the same. So look at the two number lines. You're going to notice that first of all, they both have the same mean, and they both, if you look at question number 3, have the same range. So when you're comparing and contrasting, start with comparing and telling me what's the same between the two teams. So you would simply say both teams have the same mean of 55 and range of 14. So be sure to put in your explanation what the mean and the range were. Now the second part, because we're not done yet, we have to contrast. So tell what's different. So on these, I want you to actually look at the number lines. Look at Allie's number line and look at all the pink dots the way I have them spread out. And then look at Lena's number line and see where the blue dots are put on that number line. So what we notice is Allie's team dots are more spread out, whereas Lena's team, notice like this set right here, it's a little cluster that they're clustered together. Then they have another cluster over here where Allie's team is all spread out throughout the number line. So let's talk about that. So when we write that, so we're going to write what the differences are. The data for Allie's team is more spread out, and Lena's team is more clustered. So it just needs to be kind of basic. It doesn't have to be any fancy type of talk. All right. So here we're going to define mean absolute deviation. So we've already used interquartile range to describe the spread of a data set. We've also talked about measures of center, where we've done mean, median, and mode. So now we're also going to learn how to use mean absolute deviation. So this is another thing that we can use to describe how our data values are spread out other than doing the quartiles. Mean absolute deviation is a set of data that is the average distance between each data value and the mean. So what we did on the previous page, it's going to make a little bit more sense compared to this definition as we go through the examples. All right, so let's look at number 1. So looking at example 1, it reads, the table shows the maximum speeds of 8 roller coasters. Find the mean absolute deviation of the set of data. Describe what the mean absolute deviation represents. Okay, so go ahead over on the left side. I would like for you to list the steps that we're going to be doing these. Now, I'm going to simplify the steps. It's the same steps that are here on this page, so please write neatly because you're going to want to refer back to your notes. So the first thing that you're going to do is you're going to find the mean of the maximum speeds of the roller coasters. Now they've already done this for us, so we don't have to sit there and add them up and divide by 8 since there's 8 numbers, but that's done for us, right over in this area right here. So when they added up all 8 numbers and divided by 8, they found that the mean was 64. So that 64 is really important. Now step 2, here's what you're going to do. What you have to do is you're going to subtract the mean and each data value. Now, the data values, remember, are these guys over here. So what you're going to do is you're going to take 64 and you're going to subtract 64 with each of these numbers individually, and then of course keep track of those numbers, because then we're going to have to do something with them for step 3. So let me show you what I'm talking about here. Now I did put a box next to step 2 where it says absolute value of the differences, I should say. So what you want to make sure is when you're subtracting these, the easiest thing to do is go ahead and put the larger number of the 2 on the top and then subtract them that way. So this way you assure yourself of finding their absolute values. So for example, let's talk the first number here. So let's talk about 58. And remember, we're using the 64 each time. So you would basically be doing 64 minus 58. And then when you subtract those 2 numbers out, you're going to end up getting 6 for that one. So we want to hold on to that 6. The next one is 88. So then you're going to do your 88 minus your 64. And on this one, you're going to get 24. So think about that 24. Oops. Our next number is 40. So I'm going to put the 64 on top this time so I could subtract 40. So this way we don't get negative numbers, even though they're supposed to be the absolute value. So technically we're still doing kind of the same stuff. So subtracting 64 minus 40, we're going to get another 24. Now we have 60 and 64. So we're going to put the 64 on top. And here's our 60. I get 4. So I took care of that guy. 72 minus 64. I get 8. Now I've got 66 minus 64. I get a 2. 80 minus 64. 16. And then my last one is 48. So I'm going to do 64 minus 48. And I get 16. So now that we have those numbers there, step 3, what you're going to do is you're going to find the mean of all these new values from step 2. Now, our new values from step 2 are these guys right here. We have our 6, our 24, the 4, the 8, the 2, 16, and 16. So they did this for us over here in step 3. So what they did is they added up all those new numbers divided by 8 because we have that many numbers. And then they found that the mean absolute deviation is 12.5. So over here, we're going to go ahead and put a box around the 12.5. And let me tell you what that means. So now this goes with the part 2 of our question where it says, describe what the mean absolute deviation means or represents. The mean, so if you look here, let me show you where you're looking. There you go, that arrow there. This is your describing part. So remember we mentioned how we're going to have to be doing a lot more writing in math this quarter. So if you look at this part right here, you're going to start by telling me what the mean absolute deviation is. So it says here the mean absolute deviation is 12.5 or 12.5. This means that the average distance each data value is from the mean is 12.5 miles per hour. So you guys, what we really did here is that when we found the mean of the roller coaster speeds, we then found how far away each individual roller coaster speed was from the mean of the overall set, which was 64. So that's why we subtracted everything and then found the average again. So we found that the mean absolute deviation was about 12.5 miles per hour, kind of like the distance away from them. And that's what you would do with this. So this is not, once again, difficult. It's just another process that you have to remember on what to do. All right, so now it's your turn to give this a try. So now remember, the steps you're going to have to do is you're going to have to find the mean of this set of numbers over here first. Once you find their mean, what you're going to do then is you're going to take that mean number and subtract it from or by each of those individual numbers, and then those new numbers, you're going to then find the mean of them again. All right, now I will allow you guys, if you have a calculator in handy, I will allow you to go ahead and use a calculator, and I will in class as well, because my main purpose here is to get you guys to understand and know how to do this versus testing your adding and dividing and multiplying well, we're not multiplying, but you're adding and dividing skills. All right, you guys, go ahead and pause the video and give this stuff a try. So the first thing I did is I went ahead and added up all 10 numbers, and when I did that, I got 786, and I divided it by 10, getting 78.6. Now, the 78.6 is my mean for the speeds of the top 10 fastest birds. So now what I had to do is take my 78.6 and I subtracted it from each of the numbers that were inside my data table over here. And of course, I always had the absolute value of each number, which means my numbers were always positive. So I always put the larger number on top and subtracted that way. So here you'll see that I went ahead and did that. And I did that for all 10 values. Now that I did that for all 10 values, what I did now is those new 10 numbers that I have, and I'm going to go ahead and put a box around them, I added all of those guys up and divided by 10, and I ended up getting 109.2 divided by 10, so therefore I got 10.92. Now 10 and 92 hundredths, or 10.92, is my mean absolute deviation. So now the directions told us to describe what the mean absolute deviation represents. So just like before, I modeled my two sentences exactly like the example that we did on our previous page. So I started with writing the mean absolute deviation is 10.92. Because that's what it is. So you always have to tell what it is. So now I'm going to tell what it means. So what that means is, I wrote, this means that the average distance of each data value from the mean is 10.92 miles per hour. Now, the reason why I put mph for miles per hour is because if you look over in your data table, over in this area right here, it says mph because those numbers represent miles per hour that the birds fly. And that's all that you're doing with this. So it does require a lot of work, but the concept and the process really isn't that difficult, just a bit tedious. All right, so now we're going to talk a little bit more about comparing variation. You can compare the mean absolute deviation for two data sets. That's what so what we've been doing is have been doing it for just one data set. So now, they're going to make us do it for two data sets. A data set with a smaller mean absolute deviation has data values that are closer to the mean than a data set with greater mean absolute deviations. So what that's telling us is if your data numbers are closer together, like your numbers are much closer together. Well, no, what that means is, is that if your mean is smaller for a data set, that means that your data, I can't even talk right now. So what that means is if your mean is smaller than the other one, so now we're doing for two of them, the one with the smaller mean is going to have data values that are closer together to the actual mean than, let's say, the other one. So let's put this guy to the test. So what they did with this example is, it says the top 5 salaries and the bottom 5 salaries for 2010 New York Yankees are shown in the table below. Salaries are in the millions of dollars and are rounded to the nearest hundredth. So they went ahead and just did this to the millions of dollars instead of making us write 6 zeros after each of these numbers. They went ahead and just wrote them like you see here. So for example, if you're looking at the top 5 salaries, the one that says 33.00, that means means $33 million. The one that reads 24.29 means $24,290,000. So you kind of get the idea there. Okay, so what they did here is they did everything that we just got done doing twice. So what I would do when I'm doing this is I would go ahead and find everything, and let me switch to a brighter color. I would find everything that I needed for these guys. So I added up these 5 salaries and I divided by 5, and they got this right here, 23.40. So now what they did then is they went ahead and took their 23.40 and subtracted it from each of these numbers, just like we did before, and they actually wrote that over on this side right here. So you can see how they put it off to the side for you. All right. So then they went ahead and added up all those numbers, and they ended up getting a mean absolute deviation of 4.19. Remember, this is millions of dollars for the top salaries. So then they did that whole process. So I'm going to do a little squiggly here because this separates the two parts. So now they did that entire process for these guys over here to the right. So they went ahead for the bottom salaries. They went ahead and added them all up, divided by 5, and they got 0.43 or 43 hundredths. And so then what they did is they went ahead and subtracted that amount from every number over in this area here, this guy over here, and then they ended up getting the numbers that you see here. Now, they didn't write these numbers down for you like they did over here with the other one, but then they divided that by 5, and they ended up getting 0.01. All right, so now you can see that the process they did here is exactly what we just did on the previous 2 examples. So they did everything here, it's just more work, all right, but nothing was different. So now we're going to talk about comparing them. So this is the new part for this part right here, for this section, let's say. So let's go ahead and look at Part B, where it says, write a few sentences comparing their variation. So this is how they would explain this. It reads, the mean absolute deviation for the bottom 5 salaries is much less than that for the top 5 salaries. Well, if you look here, for the bottom salaries, you guys, it was only 0.43 million, whereas the other one was 4.19 million. So you can see how it is a difference. So going back to our sentence, then it says, the data for the bottom 5 salaries are closer together than the data for the top 5 salaries. Okay, so what that means is, let's go back and look at our salaries up at the top. So now we're looking at these 2 things right here. If you look at your bottom 5 salaries, look at the way the numbers are written. 4,500s, 4,400s, 4,300s, 4,100s, 4,100s. Notice they're all really close together. Now look at the top 5 salaries. You've got 33, and then look at the smallest number, 16.50. So you can see that the range is wider. So that's really what we're talking about, is the range is a lot broader or a lot wider for the top 5 salaries than it is for the bottom 5 salaries. So when you go to explain, when you're comparing 2 different ones, tell me, of course, which mean is more or less than the other, just be consistent, and then tell me which set is closer together than the other. And you can kind of look at that a lot of times by just thinking about the range of the numbers as well. So now it's your turn to give this a try. So now what you're going to do is you're going to do exactly what you did on your own for example A. You're going to find the mean absolute deviation for both the comedy and the drama in this example. And then when you're done, you're going to write your couple of sentences, usually about 2, comparing the 2. So tell me which one has a greater mean absolute deviation, and then tell me like which set of data numbers are closer together because of that. Now you can kind of see and tell, but just go ahead and you've got to show me the numbers. Once again, you can use a calculator for this. However, when you do, I do want you to go ahead and list like what the mean was, what all the individual numbers are that you're adding together for their absolute values, and then what the mean absolute deviation is. So I still need to see something on your paper other than just one final answer and one final sentence. Okay, so let's see how we did. So I went ahead and started by finding the mean for the comedies, and I got 94.2. So you can see that I did my 94.2 and I subtracted the difference between every comedy number. So then I went ahead and I ended up finding the mean absolute deviation to be 4.16 for comedies. Now I started to do it with the dramas. So when I found the mean for all the drama numbers, I got 132.8. You can see that I went ahead and wrote them out and I started subtracting. And I ended up finding the mean absolute deviation for drama to be 12.24. All right, so now it's time to write my sentences. So between the two, I am going to basically say that the comedy was much shorter than the dramas. Because remember, this is the running time for movies. So that means how long the movies ran for. So the running time for comedies was much shorter than that of the drama. So we're going to go ahead and put that in a sentence. So I wrote the mean absolute deviation of the comedy running time is less than that of the dramas. Okay, so now we have to tell which set of data values are closer together, which really you can kind of tell before you even find the standard or the absolute deviation anyway. So then I went ahead and put the running times for comedies are closer together. So, because look at that, 98, or I'm sorry, not 98. Take the 100, which is our largest number, and compare it to the 88, and it's a much closer distance than, let's say, the 150 is with the 115. And that's it. So now what I want you guys to do is we're going to work on our guided practice. And I would like for you to do questions 1 through 3, yes, including question number 3. I know it requires a lot of work, but I will allow you guys to use a calculator if you would like. But I'm going to be checking for complete sentences. So be sure to come in with capital letters and periods and complete sentences. And to share another photo with you guys, this is a photo of a very pretty sunrise. All right, guys, that's it for now. We'll see you back in class.